Hello there, Mr. Chan here, about to do Algebra 1, Topic 1 review. Everyone go ahead and turn to page 50 of your note taker. We are going to do some review problems. As you can see on your screen in front of you, we have a vocabulary review. I'm going to go and put some answers here, starting with number 2, I guess. Sure. An equation rule for a relationship between two or more quantities is, now are there a list of answers off to the right there? The answer is formula. Number 3, a combination of two or more inequalities using the word and or the word or is a compound inequality. The key, of course, is the word ands and ors. Great. Number 3, any of the distinct objects of a set is called an element. Number 5, if each element of B is also an element of A, B is a blank of A. It's called a subset. Number 6, a well-defined collection of elements is a set. Number 7, an equation where letters are used for constants and variables is a literal equation. And number 8, an equation that is true for all values of a variable is an identity. Any answer works. Great, let's move on to the first section. Now, you may recall we did not learn the first section, so I am still going to briefly talk about it. If you want to know about operations on real numbers, 1-1, we skipped, but they do practice that. I will move on to the next section, 1-2. Let's move on to page 51. Next page. We have a nice example here on the left involving fractions. It looks like they distributed the 2/3 first, and we got 4x minus 10, blah, blah, blah. And then they went ahead and combined like terms right there, 4x and 5x, after they did the distributive property. Then from there, they combined like terms by undoing operations in that example. And we are referring to PEMDAS backwards. And moving everything away from x, they get rid of the add and subtract first by adding 10 to both sides and then dividing by 9. Great example there on the left, involving all kinds of properties. Number 16, use the structure. What property would you use first to solve this particular problem, 1/2 x minus 6 equals 10? You want to move the minus 6 to the other side, and we want to add 6 to both sides. That property is called the addition property of equality. All right, I'm going to scooch off over to the right. I have some space here, and you can kind of see this, to do number 17, 18, and so on until we get tired. We'll see if we can be able to do all of it. Let me zoom out a little bit, give myself some space, and let's do 17 off to the side here. All right, look at that 3. I'm going to apply the distributive property. Know that this is a balanced equation. I like to draw the vertical line. Multiply through by 3 to the parentheses. Now that we've applied the distributive property, we're going to undo operations by getting rid of the minus 3 first. Add 3 to both sides, of course. Oh, nice. One more step to get rid of the 6, divide by 6, because 6 is the coefficient. 6x means to multiply. We're going to divide by 6 to both sides. Yay, there's my answer. X equals 4. Next problem. Let's do number 18. Oh, 18 is very similar to number 17. We are solving for t, but before we do that, I do need to apply the distributive property. Split that equation in half. 8 times 4 is 32. 8 times 5 on the back end is 40. T is your variable you're trying to solve for. Move everything away from that. Kind of like what we did on the other side with the x. Add 4 to both sides. That leaves me with a 32t on the right-hand side equals to 140 on the other side. Divide through by 32. I don't think 32 will go into 140 equally. I have a feeling we're going to get a fraction or a decimal. In fact, if you try to reduce this by dividing by 2s and whatever, you can try to narrow it down. 140 divided by 32 will give you a decimal of 4.375 on my calculator. And there's your answer. I could have easily taken the fraction reduced. I'll just show that off to the side. I'm going to start dividing by 2s. Let's see if I can reduce this thing or not. Oh, look at that. I can keep going. Divide by 2. Sometimes I don't have a calculator in front of me. Divide by 2. And just slowly narrow it down. Oh, look at that. 35 over 8 is the reduced improper fraction. I'll take that answer as well. If you want to convert that to a mixed number, you can. You should probably write that down too, just in case. 8 goes into 32 4 times, a remainder of 3, and there's your other mixed number answer. Woo! Let's do one more for this section. Let's do number 18. Sorry, 19, duh. Okay, the variable is b. We have fractions everywhere. There's a cool trick to get rid of all the fractions in one shot in an equation. That is to multiply by the least common denominator. In this case, the denominators are 8, 4, and 12. The smallest number through which all three of those numbers can divide into is 12 itself. So we're going to do that. We're going to multiply everything by 12. 12 here and 12 there. Okay, let's hope things go away. Oh, wait a second. Oh boy, I just realized 8 doesn't go into 12 evenly, does it? Mistake. Back it up. Beep, beep, beep. Let's think of a bigger number. I'm going to think 24 now. Big mistake there, Mr. Chen. Glad I caught myself. I realized 12 and 8 don't reduce nicely and makes the denominator go away. Can't be 12, can it? Has to be something bigger. 24. It's been a while. I might as well point that out. How did I get 24, Mr. Chan? Back in elementary school, you probably did something like this. Wrote down multiples of the numbers you're trying to get the least common denominator with. So that's what I'm doing right now. Oh, there it is. 24 is the least common denominator. I made the mistake of saying 12 earlier, but I corrected myself. Whew. Thank goodness. 24, you got to multiply both sides with. You are distributing with 24, and if it's a binomial, you distribute to both of them. 24 times reduced with 8 is 3 times. That's the whole point of that, to get rid of the denominator. 3 times 5 is 15. Over here on the other side, 4 goes on 24 6 times. So that'll give you that. Better write it out. We don't want kids to be confused. So I'm writing the whole thing out so you can see the reduction right there. Boom, the first half right there, 24 and 4 is 6 over 1. And the other one is 12 and the 24, 2 over 1. Much nicer. 6 times 3 is 18. And 2 times 7 is 14. Woo. We're ready to solve. Took a little time to find that LCD, didn't it? So I added 14 to both sides. That'll give me 29 on the left-hand side. And unfortunately, when I divide by 18, it won't reduce. I am left with an answer of 29/18, which is not a nice decimal at all. Leave it as an improper fraction, that's fine. If you gave me an answer of 1 and 11/18, I guess I have to take that one as well, okay? So either one of those are fine. The next problem, number 20, is a decimal. I think that one requires a scientific calculator. And number 21, I think I'm going to skip. That takes care of the section 1-2. Let's move on to section 1-3 next. Here we go. Move on down here. Here we go. Quick review. To solve equations with variables on both sides, that's the key here. Rewrite the equation so that all the variable terms are on one side of the equation and the constants are on the other side. Then solve for the variable, the value of the variable. The point here is you need to combine terms by moving things to the other side. Notice in an example they give us, x shows up in both sides of the equation. So what they do is they went ahead and added 3x to both sides because that's the smaller x. And then the rest is undoing operations and solving by doing reverse of PEMDAS again. Same thing, just one additional thing, which is having variables on both sides. Let's take a look at our choices here. All right, let's do number 23. Here we go. Be careful, you might be tempted to cancel the 4x's because I see a negative and a positive, but unfortunately they're on opposite sides of the equation. They don't go away. They don't cancel. They're not zero pairs. They have to be on the same side to be zero pairs. In this case, if you add 4x to both sides, the variable will still be there. And that would be 8x plus 21. Now we undo operations and solve by subtracting 21 to both sides. That gives me 8x equals 0. Don't think there's no solution here. You will get 0 as an answer. Anything 0 divided by anything is 0. Great. Let's try number 24. Any questions? All right, here we go. Not a fan of the letter B because it can be confused with the number 6 very easily, but we'll make do. All right. First thing that's screaming out at me, besides the B's being on opposite sides, is the 3 distributive property. Let's go ahead and apply that. 3 times 5b, and 3 times negative 2. Oh, we need now to combine like terms, but the b's are on opposite sides. Move the smaller term to the other side. That smaller term in this case is 6b. Let's go and subtract 6b to both sides. 15 minus 6, of course, is 9b. And we're now ready to solve by undoing operations. Let's add 6 to both sides. Be careful with your negatives. Negative 27 plus 6, opposite sign, subtract. Carry the sign of the larger, negative. This will give you negative 21. Unfortunately, for number 24, I will get another fraction after I divide by 9. B is equal to, and can I reduce it? Sure. Divide top and bottom by 3. That will give me negative 7/3 as the answer. Or I will take the mixed number. 3 goes into 7, negative 2 and 1/3 times. Okay? I'll take either one of those answers. All right. I'm going to skip number 25 and number 26. Any questions on 1-3? Let's move on to 1-4. Next page. Literal equations and formulas. Quick review. You can use properties of equality to solve literal equations for a specific variable. You can use the rewritten equation as a formula to solve problems. So they have an example involving the, volume of a cylinder. What is that? A lot of you may have seen this in your middle school geometry class. Here's a cylinder, which is basically like the paper towel. The variables in there, A stands for the area, and interesting. Oh, they have a typo. I remember this from last year. That A should not be the letter A, that should be the letter V. Everybody change that. Volume equals pi r squared h. Let's change A to V. Ha ha ha, we found a mistake. All right, pi r squared is referring to the circle of a cylinder. H is the height of this. I'm just going to draw that in for you. There's radius. This is the height of a cylinder. All right, so what they're doing is that basically rearranging the formula or rearranging the furniture, like I like to say, and isolating the letter H. And after they do that, they plug in the volume that's given to them, 1,650, and they plugged in the radius, which is 6, and then they simplified it to get 14.6 centimeters high. Let's try some literal equations that are a little less complicated off to the right here. Number 28 is a great start here. You know, I just realized we might have skipped an error analysis from the previous section. Describe and correct the error of a student made when solving this particular formula. Let's take a look here. Solving for B. We should try one. All right, they multiply by the reciprocal of 3/4. That's cool. Nothing wrong with there. And in that case, okay. Then they went ahead, they swapped the 4/3 and the B without any type of like subtraction. So there's your error right there. The error should be right there. That should be -5, not +5. Okay, that's your error right there. Should not be +5, should be -5 to move it to the other side to isolate B. All right, number 28. Here we go. So we're given a literal equation. We're trying to solve for y. That's the actual variable after the semicolon, and it's right there. Now, don't freak out. It's not a big deal. Pretend the x is next to it is like a number. XY means multiply. How do I move the x to the other side? You need to undo operations by finding the opposite of multiplication, which is division. Divide both sides by x. And you're done. I know, that's too easy, right? Y equals k over x is the literal equation you just created by rearranging the formula. 29 is next. Here we go. All right. This one can get a little complicated. I'm going to accept more than one answer here, but we're trying to solve for C, isolate C here. We're going to move everything away from the C. We have that 2 divided by B. That's strange. You can actually move the whole fraction over to the other side. There's technically a positive sign right there in front of it. This is one of those weird ones. Subtract 2 over B to both sides. I know it sounds really crazy, but that's what you have to do. We're going to be creating like a complex fraction here in a second. Here. All right, holy cow. Last step, do the opposite of 3 times C. That's a divide by 3. And this is where the compounding fraction kicks in. Look at that thing, holy cow. All right, clean that up a little there. There you go. I will take this answer right there on the left. I mean, it's pretty ugly. Or I will take this as well. Watch this. A divided by 3 minus 2 divided by B divided by 3. Don't we multiply by the reciprocal of 3 over 1, which is 1/3? This will be 2 over 3B. Okay? So there's 2 answers I will take. This guy or this guy. Those are both acceptable. There's actually a third I realize that there is, but we're going to just play with that for now. In fact, in the book, they have one other possibility. They multiply top and bottom by B for the first fraction to find a common denominator, and that will give you a third answer. This is pretty crazy. AB minus 2 over 3B. That's the third possible answer, okay? Woo. All right, let's do number 30. 30 is quite a challenge. We're going to take it on though. Just writing it out, of course. And we are isolating D, and D shows up in multiple places. Shows up here and there. The challenge is buried inside parentheses. And unfortunately, we have to distribute the coefficients to the binomial parentheses in order to shuffle things around, isolate the D's, and factor out a D. It's a lot going on. Watch. Here we go. Distribute the 6 right there. Distribute the 5 right there. And let's see what happens. 6 times 2C and 6 times 3D. Woo! You're welcome to pause the video anytime. If I'm going too fast, distribute the 5. Woo! All right. I noticed that D is in more than one spot. I'm going to move one of the D's to the other side. Traditionally move the smaller one. I'm going to move negative 15D to the other side by adding D to both sides. You know what? We might as well subtract the 12C to the other side. That'll save me some time, won't it? Subtract 12C over here. Oh, great. That gives me a double move there. 20 minus 12C is 8C. All right, last step, divide by 3. Oh, no way. There it is. D equals 8C over 3, and that's your literal equation. All right? Not too bad. And double check everything. 12, 18, 20 minus 15 looks good. Subtract 8. Oh, I knew there was a problem. Wow, 2 mistakes in one video? You're kidding me, Mr. Chang. So that 3, I forgot to write down 33. I knew there was a weird, sneaky, there it is, much better, okay. I lost a number. D equals 8C over 33. My bad, sorry about that, folks. Whew. All right, that takes care of 1-4. Let's move on to 1-5. I'm glad I caught that mistake. That was pretty crazy. Here we go. We're now moving on to inequalities. You know what those look like. Let's write them down. All right, those are less than or equal to, greater than or equal to. Might be a great idea to list those names here. Less, greater, or equal. There you go. Less than or equal to, greater than or equal to. All right. Same strategies used for solving multi-step equations can be used to solve multi-step inequalities. When multiplying and dividing by a negative value, reverse the inequality. Oh yeah, that's a great reminder. Anytime you multiply or divide by a negative number, do a sign change or reverse, right? Very important there. Great reminder from the authors there. Here we go. In their example, they distribute the -2 to both sides, to the parentheses there. Then they went ahead and add 10 to both sides. Great. Then this is where the sign change just direction. They divide by -12. When you divide by -12, the symbol changes direction. So there it is. Solution is x is greater than or equal to -7. This is a closed circle because of the inequality, and it's shaded to the right. You follow the arrow from -7. All right, let's try number 32. Oh, this is weird. Why would they have a compound inequality on number 32 when we're not even in that section yet? Very strange. Oh, you know what? I'll do it. I'll just say, shouldn't this be for section 1.6? Let's do it. 2 rays, the left ray is from -1 and less than or equal to. Great, this is number 32. And 2 rays, you got to put the word or in between them. You're either on this side or that side of the ray, but not both. The other one is at 3 or greater. Interesting. Found a mistake from their end. It's not even in the right section. 33 is next. Solve each inequality and graph the solution. X plus 8 is greater than 11. Great. Subtract 8 to both sides. Oh, this is a one-stepper. Nice. Ooh, x is greater than 3, which means it's going to be an open circle. And you're going to draw the ray to the right of 3. Open to the right. All the numbers to the right of 3, not including 3, are part of the solution. 34. All right, let's deal with this one. Solve for x. Subtract 3 to both sides. 4x is less than or equal to, watch out for your negatives. -6 and add it to -3 is -9. Oh, we're going to get a fraction. Ouch. Let's graph that. Divide by 4. This will give us x is less than or equal to -9/4. Got to circle this one earlier. This is fine. Now, -9/4, you got to convert that to a mixed number so you can graph it literally, -2 1/4 on the number line. Negatives on the left side. Negative 2 1/4 is right about there. This time it's a closed circle to the left. Close to the left. Great. All right. Let's do number 35. Not looking forward to the decimal, but I'll deal with it. 2.4x minus 9 is less than 1.8x plus 6. Let's keep our fingers crossed. Hope these numbers come out nicely. Move the smaller x term to the other side. Ooh, opposite of positive 1.8 is negative 1.8 to both sides. Subtract. That'll give me 0.6x minus 9 is less than 6. Let's start solving. Add 9 to both sides. Okay. 0.6. X is less than 15. That's a weird number. We're going to have to divide by 0.6 to both sides. I hope I get a nice number here. X is less than, would you believe it, 25? How the heck did I get 25? There's a trick to this if you don't have a calculator. Move the decimal point 1 over, you get 150 over 60. 6, I'm sorry. And 6 will go into 150 25 times. Isn't that weird? You can always use a calculator, of course. This, of course, when you graph it, will be open circle. And at 25, it's going to the left. All right. All right, number 6 is next, 36. We haven't had to switch the direction of the inequality, but something coming up might be something where we have to switch the inequality after we distribute the 4. I'll show you in a second here. All right, distribute the 4, we'll get 4x minus 4 times 1.5 is 6. Watch this. This is interesting. We're going to subtract 3x to both sides. And our variable now is on the wrong side when it comes to inequalities. So add 6 to both sides. This will give me x equals to negative 2. Oops, sorry. X is less than or equal to negative 2. How do you read that backwards? Notice I read it backwards. So if you want to read it properly, swap the x and the negative 2 like a mirror image. See how I swapped those two, x and negative 2? And that means that inequality symbol also switches like a mirror image as well. There it is. Isn't that interesting? So if you swap quantities, you also switch the direction of the sign. Something else to keep in mind. Let's graph that. It's a closed circle at negative 2. And it's going to the left. To the left, to the left. Ooh. All right. I think we're ready for the last section. Any questions? Let's do it. Let's move on to the last section here. Here we go. Compound inequalities. All right. Compound inequalities involves ands and ors. Ands are referring to intersections of two rays. Like Sparks Boulevard and Dis Drive, where they cross is where the two streets intersect. For intersections, you want to look for the overlap. Or is the other word, which is union. Here, you just, doesn't really matter. You just graph all of it. You don't have to worry about it. An example on the left has a compound inequality involving 1/2 right there and the other one, and they're both split up. When they're like that, this is an and situation. You solve them individually, you see where they overlap. Notice those rays after you solve it, they overlap between -5 and +2. They overlap in the middle where they cross each other. That's why that's the graph itself. Describe and correct the error for number 38. A student made graphing the compound inequality x is greater than 3 or x is less than -1. X is greater than 3 is going to the right of 3. Should be like this. It should be open circle as well. This is an open circle. Should be going that way. And the word or also makes this very different. This is a union. And we're going the other way at -1. It's also open circle. -1. And it should be going to the left. So it should be two separate rays, and that's where they made a mistake. They literally gave us, you know what, we might as well put that down. They literally gave us -1 is less than or equal to x is less than or equal to 3. That's a compound inequality, and that's an and situation or an intersection. That's what they have given us. All right, let's crank through a couple of these. I don't know if I want to do all of them. At least 39 and 40. Let's do that. All right, here we go. 2x minus 3 is greater than 5, or the other half is 3x minus 1 is less than 8. Solve them individually and graph them. Add 3 to both sides. On the first inequality there, 2x is greater than 8. Great. Divide 3 by 2. X is greater than 4. Okay, that's the first half. Or, let's do the other half. Add 1 to both sides. 3x is less than 9. Oh, nice. These are coming out nice and whole. Divide 3 by 3. X is less than 3. Sweet. All right, this is an or, which means this is a union. You just graph all of it. You don't have to worry about any overlaps on the number line. 4 and 3. Both open circles. And you just graph them. That's it. At 4 greater than to the right. At 3 open circle less than to the left. And that's it. I think we need to do one more. Let's do number 40. Maybe I'll change my mind. We'll see. X minus 6 is less than or equal to 18. And 3 minus 2x. Oh, we see a negative sign right there in front of the x. That's kind of worrisome. Is greater than or equal to 11. I'm a little worried. This might be a problem they did not intend. I already see a problem. We'll see. We'll see how it goes. All right, first inequality, add 6 to both sides. That gives me x is less than or equal to 24. That's a crazy big number. Okay, fine. And, which means intersection of two rays. Okay, let's solve this one. Subtract 3 to both sides. -2x is greater than or equal to 8. Divide 3 by -2. I believe they made a mistake. If we divide by -2 right now, that inequality changes direction and it's going in the same direction as the other one. So I'm going to make an executive decision right now and change the original problem to the other direction right now, like that. We'll call that a typo. I think they really, yeah. And let's erase that too. We're going to change it. I knew it. So when we divide by -2, next step, because we're dividing by a negative number, it does switch the inequality, right? In the other direction. Now it makes sense. There it is. Positive 8 divided by -2 is -4. We now have an intersection of those two rays. 24 is kind of crazy there. All right. Not drawn to scale. Ha, 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 ha. These are both closed endpoints. At -4, it's greater than or equal to -4. So it's closed circle. And it's going to go to the right. Now you notice I'm just kind of eyeballing it. Excuse me. Sorry about that. And I have a ray going to the right of -4, including -4. At 24, it's closed as well. But this time it's less than or equal to goes to the left. So visualize where they cross in the middle. And there's your answer. Okay? It's a segment with endpoints -4 and 24. Well, I think that does it for our review of chapter 1. See what happens if I zoom out a little bit. I will post this on my website, the answers themselves, those are it. If you have any questions, ask me in class. Thank you very much. Have a nice day.